Principle of moments. I write it as POM so that it becomes easier for you. Now, principle of moments, it's applicable only when body is in equilibrium. So which equilibrium, dynamic or static, doesn't matter to me. Body is in equilibrium, that's it. Because I'll be just using net force is equal to 0 and my net torque is equal to 0. And majorly I'll be concluding my questions with net torque being equal to 0. Majorly I'll be concluding all my questions with net torque being equal to 0. That is nothing but summation of moments. So principle of moment says, or it states that sum of anti-clockwise movement, okay, is equal to sum of clockwise movement. Sum of anti-clockwise movement is equal to sum of clockwise movement. Fine. Now, you can also state that summation of all the movements about a point is equal to 0. That is, sum of anti-clockwise plus sum of clockwise is equal to 0. Fine. That is also there. Why am I? You can also write it as sum of anti-clockwise movement plus sum of. The statement is also correct since it is objective paper. I'm writing the statement also. Sum of anti-clockwise movement plus sum of clockwise movement is equal to 0. This statement is also valid because I'm writing this side, doesn't matter. So now, sir, you are adding both the movements. How will it be equal to 0? Sir, clockwise is positive. Sorry, anti-clockwise is positive and clockwise is negative moment. This is positive and this is negative. So when you add, when you do the algebraic summation of this, it is equal to 0. It has to be equal to 0 if it is following principle of moments because it's an equilibrium. Net torque has to be equal to 0. What is ACMCM? Torque. Be it clockwise, be it anti-clockwise. It doesn't matter to me. If it is an equilibrium, my net torque has to be equal to 0 as per the given condition, right? So it has to be equal to 0. Yeah. Now, based on this, there are plenty amount of questions which are there, okay, and that's something which is the most important because at least 1 or 2 questions will turn up on principle of moments. At least 1 or 2 questions will definitely turn up on moments. Okay. So based on that, there are numericals. Apart from that, there is nothing else. So where you need to focus is only the numerical part. The numericals are the most important. Short 2 questions pop up from here. 2 questions in your books pop up from here. What do you have to do? That's it. Nothing else. You don't have to. You just have to find the weight of the scale or some mass or something. Let's say, for example, take a scale, meter scale. Meter scale of 50 gram. Pivoted or hinged at 40 centimeter mark. body. I'm not framing it in proper statement, just get the gist of it. A body of mass m is suspended at one end. Question is, where should the mass m be suspended? And what should be the value of m if scale is in equilibrium? Now, conditions apply over here is that whenever you get this word in these type of questions, 100% of the times this word will be there. If it is not there, that's something we should think about. That is nothing but a different type. But whenever this is being mentioned, so close your eyes and just apply principle of moments. Close your eyes and just apply principle of moments. But definitely before that, you will have to draw the diagram and all the stuffs. So here, if I have to just draw this diagram, if I have to represent this, it's a meter scale. So meter scale indicates it starts from 0 and it ends at 100 centimeter. It's preferable if you write it in centimeters. So, and always mark the center, which is the 50. So at 50 centimeter mark, this weight or the mass of the scale lies, because this point is nothing but your center of gravity. This particular point is the center of gravity of the scale. And here the weight is 50 gram force. Please write gram force. Don't just write grams. Don't just write grams. Now, where is it pivoted? It is pivoted at 40 centimeter mark. Now, whenever you have the statement or in the question you have this word mark, it means the exact location or the exact position. Mark always indicates it's the exact position. Mark always indicates that. So where is 40? 40 somewhere here. So at this particular point, I'm writing it is 40. So what's the basic? What's the distance from here? 40 to 50. It's nothing but equal to 10. So I'm writing over here and encircling. Now there should be a mass of m, which is again suspended at one end. Now which end will it be suspended? See, this one weight is already there at this side. So the another weight has to be on this side. If you're placing one weight over here, then the scale will bend totally towards the right. But in order to avoid that, we are trying to suspend this mass this side. We're trying to suspend. Why? Why am I doing that? Because it's given in the question that it is an equilibrium. It's an equilibrium. So, and since it is telling at one end, I'm placing it at the end, that is 0 mark. But what if it has not been mentioned, it is at one end? So the distance will be mentioned. At that point of time, we will work on that basis. Now, this particular distance is 0 to 40 is nothing but 40 centimeter. Encircle that. So, anti-clockwise movement is equal to clockwise movement. So, mass, again, this weight is acting in the downward direction, arrowhead towards the pivot. Arrowhead towards the pivot. So, this is producing anti-clockwise movement. And this is producing, or this side force is producing clockwise movement. Anti-clockwise is nothing but, now will I write m? Please don't write m. It's better if you write some random weight w into 40, which is equal to 50 into 10. Why am I writing w and instead of mass m? Because it gives me the weight to find. But since it is objective paper, it doesn't matter. You can write m also and you can solve your question. So weight is equal to 50 into 10 divided by 40, which on calculating 4 ones are 4.
12.5 gram.
12.5. It is gram force. You always find out the weight. You never find out the mass. Now, if weight is so much, therefore, mass is equal to 12.5 grams. Please be very careful with the units. That's something which I am telling you. Now, definitely values will be given as 12.5 when in your examination, but in the units is something they will try to play around. The units is something they will try to play around with it. So please focus on that. Anyone who didn't understand this example, let me just try to give you a question. Try to solve it. Do not solve in your notes. Try to solve it in your practice book because notes were halfway through this current wala chapter. Actually. Um, See, if I have to rephrase this 40 centimeter mark, I can also mention it as 10 centimeter to the left of center of gravity. Now, meter rule, this is the meter rule, which is the center of gravity. 50 centimeter mark, and towards the left by 10 centimeter is how much? 40 only. So it can be rephrased. It remains the same ultimately. Oh, I didn't answer this over here. Where should the mass m be suspended? Mass m should be suspended at 0 centimeter mark, or should be suspended at 0 centimeter mark. Suspended at the distance of yes. Try to solve this also. Anyone with the answer?
So 12.5 gram.
Twelve point five.
All right, everyone's done. Is anyone still doing?
Yes.
Yes, sir. Done.
It is the same previous question itself. I've just rephrased that, nothing else. Meter scale 0 to 100. Okay. Weighing 50. So I told you immediately mark the center point. That is the center of gravity. So what's the weight of the scale? 50 gram force. Now this is pivoted at 40 centimeter mark. So let's say this is 40 centimeter mark and there's a pivot over there. What's the basic difference? Sorry, the distance between 40 50? 10 or 10 to the left of center of gravity. This is the center of gravity, 10 centimeter towards the left. A mass M is suspended at a distance of 40 centimeter to the left of pivot. Which is the left? This is the right of pivot and this is the left of pivot. So 40 centimeter from here is nothing but 0 centimeter mark. Here there's a mass M which is being suspended. This distance is 40. Same previous question is previous questions. Now again, this will produce a torque this side and this will produce torque this side. So clockwise, anti-clockwise is the same calculation. So mass is equal to 12.5 gram, not gram force, 12.5 gram. Yeah.
Yes.
Any doubts?
No.